So here we go. We're going to be doing logarithmic functions in the graphs. And so once again, we're going to demand that a is greater than 0. We're not going to do anything where a is not greater than 0 for either base a for log or base for exponential. So we say log base a of x is equal to y. That's how you say that. Log base a of x is equal to y. So that's how we say that. And that is the same thing of asking is a to the y equals x. And so what so log base a of x, ask the question, and this is what you kind of need to put in your mind. Ask the question, a to what power is x, right? And so that's the question you need to ask. And so here, a to what power is x, and so here let's convert these, and then it's easier for me to explain what's going on. So this, according to this, so this would be base 10. So our base a is always the same base, is 3 is equal to 1,000. Okay, so now that I have this, it's easier to explain. 10 to what power is 1,000? Well, that answer is 3. 10 to the third power is 1,000, right? Here we can do this. 2 to what power is 64? Well, that answer is 6. To the 6th power is 64. Okay. And 16 to what power is 4? Well, it's the square root of 16, or 16 to a half power, right? Which is the same thing as the square root of 16. Okay. And so the log function basically, so you'll see all of this, right? And so say log of 10 to, so you think 10 to what power is 1,000? And the answer is 3, right? You'll see all of this. 2 to what power is 64? The answer is 6. And then you'll see this, 16 to what power is a 4? And that's a half. Okay, so that's how logs work. So this is the inverse function. So the log is the inverse of the exponential. That's literally how it's defined. It's the inverse function for the exponential function. Okay, and so exponential is 1 to 1. So notice it passes our horizontal line test and everything. So this actually can have an inverse. What's that inverse? We just defined that to be log. Okay. All right, so convert the following exponential functions into log functions. So here, if we're going to go backwards, it'd be the log. The base is always the base, so base 10 of 0.1. So 10 raised to 0.1 is what? It'd be -1. For here, it'd be log base 5. The bases are always the same, is 125, and the answer here is 3. Okay, and then here, for this last one, the log base 3 of 81, 83 raised to what power is 81? And the answer here is 4. Okay, remind me and I'll take you in a second. Remind me at the end. I'll mark it. Okay. Oh, hold on. So another question. This is 64. Sorry. So this and this are the same. Okay. All right. So here, let's graph a couple x in order to graph this. And here I'm going to do just powers of 2. Because then if I take the log base 2, it's just 2. So if x equals to 4, the log is 2. If x is equal to 2, the log was 1. If x is 1, it was log of, it was 0. And then here, if I have to the minus half, I'll have a half, and that makes this -1. 2 to the minus 2 is the minus is the 4th. That's minus 2. 8, and then 2 to the, well, let's just do the third power real quick, and that'll be 8. I should have put this up here, but that's okay. This would be minus 3, and this would be 3. All right. So here, let's plug in those points, and notice what we'll have here. And so I'm going to graph my log in this, and I'm going to graph my exponential in the other color. So here at 1, I'm at 0, right? So 1, I'm at 0. Here at 2, I'm at 1. And here at 4, I'm at 2. And then here at 3, I'm at 8. And then here at 8, I'm at 3, sorry. And then here at a half, I'm at minus 1, minus 2. And then 8th, I'm like minus 3. And so this comes in and goes to this asymptotically. And so this is my log. We know how to graph this. We've done this 1,000 times. It goes through here, goes through 2, 4, and 8, and then okay. And notice here, let me just use a completely different color. If I have my y equals x line, notice how this is just a reflection across that. And so it is indeed an inverse. And notice here that both of these pass the horizontal line test. And so both of these are 1-to-1. All right, I'll leave that up for a second. All right, so here we have the common log function. So log function 10 is called the common log. It's often omitted by writing the base. So log base nothing is often log base 10. Okay? This you have to be very, very careful about, right? And so let me write this as clearly as possible. Let me write it in red. Be careful of this. I would say about 30% of all textbooks, when it has log base nothing, they really mean what's down here, which is the natural log. So if it's log base e, it's ln of e. So we just say natural log of x, or log base e of x. And so we almost say ln of x. But 30% of your books, right, of books, log base x really means log base e of x. So never trust this. Never ever trust this. Make sure exactly what it's talking about, okay? I'm like 90% sure your book uses log base 10. A log of nothing is log base 10. Like 95% sure. But just because I've seen it done wrong so many times, because it's not as standard as you think it'd be, let me triple check it. Let me triple check. Yes. So here, I know you guys can't see and definitely won't be able to see in the video. It says log base 10 of x is x. So in your book, you're good to go. It is as written, okay? So let's run through this real quick. And so here, let me just graph these two. Yeah, so here we go. And then I'm going to open up Wolfram Alpha, or not Wolfram, but Decimals to show you some stuff. So here I have log base x. So we'll have 10, we'll have 6, we'll have, let me just use the numbers I have on cheat sheet: 4, 1, 0.5, 0.25, and then 0.1. Okay. So for 10, it's going to be 1. For 1, it's going to be 0. And from 0.1, it's going to be -1, right? Because 10 raised to what power is 10? Well, that's 1. 10 raised to what power is 1? Well, that's 0. 10 raised to 0 power is 1. And then 10 raised to what power is 0.1? It's negative 1. But what about everything in between? Well, everything in between, we're going to have to use Wolfram Alpha. And let me show you how to type it in Wolfram Alpha. And I think Wolfram Alpha uses the opposite. So here you just type in log, and you put base, and then you're going to put 10. And we'll put in 10 and see what we get. So log base 10 of 10 is indeed 1. So if we had log base 6, so this is log base 10 of 6, we get 0.7, right? Log base 4, we get 0.6, right? And so you can just type all this in. Now let's ask the super fun question, right? What does Wolfram Alpha think log base nothing is, right? If I just type in log and then 10, I get, oh my goodness, guess what Wolfram Alpha thinks log is? Wolfram Alpha thinks log is log base E. Assuming log is the natural logarithm right here. At least it tells you. At least it tells you correctly, right? I assume you meant the natural log, right? You can tell it to use the other log, right? But most of the time, when you want natural log, you're going to type ln of E, because the natural log of itself should be 1, right? And so ln is how you... So here's case in point. Wolfram Alpha thinks log means natural log, not log base 10. At least warns you kindly, right? At least warns you kindly when you type it in. It says, assuming this is the natural log, you can tell it to do the other one. So my suggestion when you type in any log, just put a little dash. So you just put the underscore. The underscore is shift minus, right? And then 10. And then you'll get exactly what you want. Okay, does that make sense how to type this in? You're going to have to do a lot of typing this in. You can use your calculator and all that. So anyways, let's put in the data points real quick. And then I'm going to show you a bunch of graphs. I'm going to show you a whole bunch of graphs. All right, so here we'll have, this is like 0.78. This is 0.6. This is like minus 0.3. This is like minus 0.6. And so when we graph this in, we'll start here. And then here at 10, I'm only at 1. So it's like out here is 1. At 6, which would be here, I'm at 7.8. Here at 4, I'm about point here. And so it comes in, goes through, comes back down, goes like this. Okay. So this is log base 10. Here in red, let's do log base 2. So here it's here again, and then it goes to here, here, and here. And so it looks something more like this. And so notice what happens here. In fact, in order to do this, let's open up Desmos, because I can just describe it way better in Desmos. Show you exactly what's going on. Desmos, where are you at? Desmos.com. All right. So here, we'll type in log. I'm super curious here. Log of, because if I type in log of 10, it should just graph a single number. All right, so here, Desmos thinks log of 10 is 1. Therefore, Desmos believe log is log base 10. All right, so here we're going to have log base 10, and we're going to graph x. Okay, here we're going to have log base, log underscore 2 x. Okay. All right, so here, let me kind of move this over. So notice that none of these graphs ever pass the x equals 0 line, right? None of them ever pass that. And let's just graph another one. Someone give me a random number in chat. I don't care what it is as long as it's positive. 6, thank you. 6 x. So that's here in blue. And then I'm going to do one more with you. I'm going to say log base 0.3 x. Okay. Oh, I guess I don't want to get to that far yet. Let's do 1.5. Okay. So notice what we have here, right? So here, the stronger the log, so here's 1.5. So the bigger the number, the more flat this is. So here it's 10, it's pretty flat and it slaps against this thing real fast. Here at 1.5, it's kind of more curved and it comes in like this. But they all go through what point? 0, 1, right? Because any function raised to the 0 power is 1. Okay, so they all go through this point. The same reason that all the exponentials. I'll just graph the exponentials of some of these real quick. 1.5 raised to the x, right? So notice how these two are inverses, and these all go for 0, 1. The logs all go through 1, 0. Okay? They all go through 1, 0. Now, the one thing I do want to show you real quick is if we switch this. So let's get rid of all these for a second. So remember, if this was 0.5, so if it was less than 1, it was exponential decay. Now, if I do the log that way, instead of it is always positive and then it goes through 0, 1 again, it becomes negative. Okay? And so here, the same thing as if this is less than 1, we flip this over the x-axis. If this is less than 1, we flip this over. No, we flip this. If the exponent, let me say this clearly. If the exponential is less than 1, instead of going up like it did, let me just draw that in. All right, here we go. That's fine. Let's go to this. All right, so here, if it's greater than 1, it increases and goes up, right? Here, if it's less than 1, it decreases and goes down. Same thing for the logs. Let's go to these two. So here, if it's greater than 1, it starts at negative and goes up like this. And if it's less than 1, oops, wrong one. Log of 0.5. It starts like this and goes down. Okay, so this is just a flip over this. All right, so that should give you a general idea of how they all go down. So let me write down some general things for logs for you. And you know what? Let's just quickly sketch in green. Log, oops. Fine, we can do black box fine. Log base of 0.5x. And here 0.5x will come in, go through this, and then go back out that way. Okay. So that way you just have this as a reference. All right, so what are some of the common things? All right, so let me write down some very common things amongst all the logs. So all the logs will have the point. All the logs have the point of 1, 0. Okay, all logs have this point. Kind of like all exponentials have the point 0, 1. The domain is always the same. It's from 0 to infinity. So we can include 0. So notice here, I can't plug in negative x's. That doesn't make sense, right? And the reason that doesn't make sense is because if I'm looking at log base 10 of like negative 2 is equal to what? Well, 10, that means 10 to what power equals, or 10 to what power equals minus 2? Well, 10 to no power is going to give us negative numbers, right? And so that's why the domain doesn't include negative numbers. It just doesn't work. Oops, I'll get rid of all that. Right on the right layer. The range for these is always going to be from minus infinity to infinity. Oops, there we go, minus infinity to infinity. That's for all, and this is for all of them. And in general, if a is less than 1 and greater than 0, it'll look, it goes like this, right? And if a is greater than 1, it goes like this, right? So it comes down or goes up, right? So this is what they look like in general. And the larger the a for this, the larger the a, the flatter it is. So it gets flatter. Okay. So that's some stuff in general. The natural log function shows up so much. We often write it, we do this. I almost exclusively use the natural log, period. What does it say about the domain? The domain is from 0 to infinity, not inclusive, right? Domain is from, you can't have 0, but everything from 0 to infinity, so parentheses 0, comma, infinity. So it's always above the domain. Oh, you always have this point. You always have let me write the point. You always have the point 1, 0. Everyone has that point. Okay, sorry, that's a good question. And every log goes through this point right here. Okay, so when we have natural log functions, log base e, this shows up so much. We use ln of log. Technically, if you know ln of log, you can do all the logs in your calculator. And I think I go over that. No, I don't go over that. That's fine. I think I'll actually do it in properties of log later. So here's some properties of logarithmic functions. So here we have log base a of 1 is 0. That is also the same thing of saying you have the point 1, 0, right? This is the same thing. Log base a of a is a, and why is that? Well, that's because a raised to what power is a? Well, that means a was raised to the first power, right? Log base a of x means a raised to what power is a of x? Well, that's just x, right? And that's also, these two are the inverse functions, right? So here I'm taking my exponent. Now let's go back to it real quick. Let me show you this be easier. This function is an inverse of this function, right? And this is just a weird, really clear way of saying it, right? Log raised to what power is a to the x? Well, that's log raised to the x power, right? And here we have the backwards. If I raise a to the log of base a of x, I get back x. And so these are just the inverse. It's just saying these are inverses of each other, right? Just saying they're inverses. So we're going to evaluate the following without using any calculator whatsoever. So ln of 1. So ln of 1, what is the value here? Well, here it's 0, right? So log base e, doesn't matter what it is. Log of any function is 0. All right, so for c, does anyone know what the answer here is? What is e raised to the ln of x? Does anyone know what this answer is? Let me rewrite it for you real quick. Yeah, it's x. Because this will be e raised to the log base e of x. And notice from here, that's just going to equal x. 3 raised to what power is 81? Well, that's the 4th power. And so I can rewrite this as log of 3 to the 4th power, and that just translates to 4. Log base 10 of 10 is 1. What's the answer here for f? Log base of 342 is 1. Or 342 raised to what power is 1? The answer for f. Does anyone know? 0 is correct, yes. Log of any base is of equal to 1 is 0, yes. All right, does anyone have a guess what this one, log base pi of pi to the 3/4 power is? Does anyone have a guess what this one is? Go ahead and just use this property right here. No guesses? Yeah, 3/4, yeah. And so here I have log base pi to the 3/4 power. Well, that just means 3/4, okay? You'll get used to running through these, and we'll look at some of the homework in a second. All right, so let me just do something. So perception of loudness. So perception of loudness is measured in decibels, which is given by the following. Log base, it's 10 times the log of b, where I is the where I is the quote-unquote loudness and I naught are the intensity, right? And I naught is the sound of a barely audible sound, right? So something that's barely audible is I over I. And so if I did that, you get log base 1, so we'll have 0 decibels. No, I said we'll have log base 10 of 1, which would be 0, right? So I get 0. So something that is absolutely barely audible is that. So find this if it was 100 times that. So here, we're going to just crunch through this real quick, and then I'll bring up what I'm really talking about. So here we have 10 log. So 100 times I naught, so the intense, so I equals 100 times I naught. So I'll just plug that in. So I'll have 100 I naught over I naught. So that means V equals 10 to the log of, well, these I naughts cancel. So 100, that means 10 to the log of 10 squared. So this means that this is 2. So it'll be 10 times 2, which is equal to 20. So something that's 100 times louder than barely hearable is 20. So I'm going to put a little star right here.